A very good morning to all of you. Today I'll be talking about big data, and there are a collection of tools in big data Hadoop ecosystem, and I'll be talking specifically about Hadoop and the components under Hadoop. Okay, so what do you mean? What do you mean by big data? You would have heard about this terminology, big data. What makes data as big data? So there are some characteristics using which we can define big data. So usually we define big data using 3 V's. Okay, volume, velocity, and variety. And we can also add some more V's to this definition. Okay, so I'm not going to focus more on the theoretical part because we have limited time. And in this limited time, I just want to give you a demo on how you can execute a Mapreduce job in Hadoop. Okay, so big data is similar to small data, but bigger in size. Having big data bigger, it requires different approaches. So say for example, already we have already handled large amounts of data using relational database management systems. Okay, so what is the limitation of you making use of the existing RDBMS system when it comes to big data? Because we are going to define big data in terms of volume, velocity, and variety. Okay, the huge amounts of data. We're not going to talk about data in terms of KBs, MBs, or GBs. We are going to talk about data in terms of terabytes, petabytes, and zettabytes. Okay, huge amounts of data. And also we are going to talk about data that flows into the system at a very high speed. Okay, and also the real-time data. So not only we are going to perform some analytics on archived data. Okay, we are not going to perform some analytics on usually how the businesses benefit from analyzing the data. They will maintain a data warehouse, the historical data. So they'll be doing some analytics on the historical data to gain meaningful insights out of it. So now, as of now, analyzing only the historical data is not enough because every moment we have the business has got huge access to huge amounts of data because with the advancements in the internet technologies, anything and everything is generating data. Anything and everything that is connected to the internet is generating data. So you'd have heard about the terminology Internet of Things, isn't it? So what do you mean by Internet of Things? Earlier only the people get connected to the internet through the computer devices, but now you can connect any device to the internet. Okay, so you can have a smart fridge, you can have a smart chair, which will have the capability to make decisions. Okay, a smart fridge can suggest to you a recipe, okay, based on the ingredients that are present available in the refrigerator. Okay, and if the milk is going to expire, it will be able to give you an indication that this particular product is going to expire in another 12 hours. So like that, it is going to give you some intimation to you so that you know what are the items that are present in the fridge and which are the items you need to buy. Okay, such kind of activities can be carried out by a smart fridge. So what about smart chair, smart mic? Okay, so anything that has the capability to make decisions, we call it as smart things. Okay, so now we are able to connect any device. So when I am at work, I just want to turn on my microwave oven to cook some food. Okay, I can turn on my electric cooker to cook the rice. Okay, something I can do it remotely by connecting my devices to the internet so that I can control the devices. I can control the devices remotely. Okay, that is the objective. So anything that is connected to the internet is generating data. So every business has got access to huge amount of data. So when the businesses have access to large amount of data, how they can benefit from the availability of such large amount of data? That is the question. Okay, so that is the reason why many of the businesses are interested in performing big data analytics. Okay, so that they can gain meaningful insights out of the data and they can make use of every opportunity. Say, for example, one of the customers is in travel and he is through the dynamic detection of means the business will be able to identify the current location of their customer and they'll be able to perform some analytics on the customer's data, like what are all his preferences, what is his food preferences, what is his buying preferences. Based on that data, they just want to suggest a retail store, okay, where there is an offer for a particular product, the customer may be interested to buy. So such kind of analytics, we call them as real-time data. The business, any of the businesses does not want to lose any of the single opportunity to sell their business, to sell their products and services. Okay, so that is the objective. That is what we call it as real-time analytics. So based on the current location of a customer, the business wants to suggest a retail store, okay, where the customer may be interested in buying his favorite product, okay, or his favorite, he may be interested in trying his favorite food, okay, something like that. So that is what we call it as real-time analytics. Such kind of real-time analytics was not possible by making use of the existing RDBMS systems. So in RDBMS systems, we have limited capacity to store the data, okay, but in case of big data, we just want to store huge amount of data, okay, with the existing RDBMS systems, we will not be able to handle such large amount of data, not only the data in terms of size, but also the data which will have the capability to flow at a very high speed into the system. Okay, that is what we call it as velocity, the speed at which the data is going to flow into the system, as well as the variety of data. Okay, existing RDBMS systems will be able to handle only, they'll be able to handle only structured data, isn't it? So some of you would have already studied database management systems in which you will be handling structured data. What do you mean by structured data? Can anyone answer? What do you mean by structured data? You can make use of your chat window to respond. What do you mean by structured data? Anybody is responding? Can I see the chat window, Divya?
Ma'am, I'm sorry, like students cannot type in the chat, but they can unmute and tell the answer.
Oh, okay, okay.
How
no
chat
issues.
is disabled for them.
Okay, if they're comfortable speaking, no issues.
Yeah.
Otherwise, I can proceed further.
Okay.
Anyone wants to answer? What do you mean by big data? What do you mean by structured data? Okay, no issues. So the meaning of structured data is any data that is organized into rows and columns. A table of data can be called as structured data, isn't it? A table of data can be called as structured data. So you have structured data with you. Okay, existing RDBMS systems can handle only structured data, but 80% of the data that is available on social media is unstructured category. Okay, they are unstructured data. So what do you mean by unstructured data? Examples for unstructured data will include video files, audio, plain text, okay, the reviews that you post on Instagram or Facebook, okay, the feedback that you give, the comments that you pass, all those that come under, okay, the images, in picture files that you share, videos that you share, all those will come under unstructured data. So 80% of the data that is available via social media will come under the category of structured data. So how any business is going to make use of such kind of unstructured data as well as semi-structured data. Okay, so we have a variety of data with us. So not only structured data, we need to process structured, unstructured, and semi-structured data. So obviously traditional database management systems will not be able to handle unstructured data and semi-structured data. So that is the reason why we need a new tool. Okay, unstructured and semi-structured. So now what are the challenges? Volume. We need to handle huge volume of data, and also we need to handle the velocity, the speed at which the data flows into the system. And then we are going to talk about the variety. Okay, the variety of data that you need to handle. Okay, so because of these characteristics of big data, existing RDBMS systems are incapable of handling big data. Okay, because of these characteristics of big data, existing RDBMS systems are incapable of handling big data. That is the reason why we go for a new tool called Hadoop. We go for a new tool called Hadoop. Okay, so this is a theory we can see here. So the different sources of big data include social media, block box data, stock exchange, transport data, power grid, search engine. So these are all the sources from where we can have access to big data. Okay, so these are all the characteristics using which we can define big data: velocity, volume, and variety. Okay. So what do you mean by velocity? High frequency stock trading algorithms reflect market changes within microseconds. So if you see here how much amount of data that is being generated in Facebook, that is being generated in Instagram, if you take any social media, the amount of data that has been generated within a fraction of a second is a huge amount of data, that will be in terms of petabytes or zettabytes. Okay, that is the reason why we say every moment huge amount of data is being generated. Okay, so how we are going to handle such huge large volume of data, as well as if we are not going to store them effectively and process them efficiently, will not be able to achieve the benefits of big data. Okay, so because as of now the oil is no more an asset. Okay, we are in an era where we call data is the new oil. Okay, data is more valuable than petrol. Data is more valuable than oil. Okay, so that is the reason why everybody is interested in. So your data and my data, in data about common people. Earlier, people were interested in knowing data about the renowned people, okay, the celebrities. But now every business is interested in knowing information about the common people too. That is the reason why whenever you access any of the free applications, okay, why that has been given for free? Because when you use any application for free, obviously they are going to take your data as the fee. Okay, so your data will be their resource. Okay, so every data about every individual is valuable now. So many of the businesses are interested in capturing information about the common people. Okay, so that what is the objective? Why the businesses are interested in getting information about the common people? Why? Because they want to sell their products and services based on their preference. So when I have my vacation, I just browse on Google saying which is the nice place to visit during the summer. Okay, so I just make a search query to search for something. Immediately when I watch a YouTube video, I'll get a relevant ad related to what I searched earlier. Okay, how that is happening? So whenever you have been, in simple terms, what I can say is we have been tracked. We are under surveillance. Someone is monitoring us. Okay, so when you are connected to the internet, you don't have any privacy at all. That is what I can say bluntly. Don't have any privacy. Someone else is monitoring you. Someone else is controlling you, or someone else is tracking you, where you are, what are you doing, which of the websites you browse, how much time you spend in each web page. Okay, what are the stores you visit, which are all the items you buy, what are your preferences, what you like, what you dislike. Okay, so from the comments, from your activities that you post in the social media, some of the businesses will be building a customer profile. Okay, what are your likes, what are your dislikes. Okay, all those things they will be building about your personal values, your business values, everything they will be building in. They will be constructing information about every single individual. So that what is the objective? They will be able to target specific people for selling any of the specific products and services. That is the objective. Okay. So if you see here, Facebook ingests 600 terabytes of new data every day. Okay. The smartphones, the data they create and consume, sensors embedded into everyday objects will soon result in billions of new, constantly updated data feeds containing environment, location, other information, including video. So just like that, we are keeping all our information accessible to everyone. So whenever you browse a website, what you see? Immediately you will see a pop-up saying cookies are enabled, isn't it? Cookies are enabled. Okay, earlier we were not we were not having such a provision saying already they were using the website websites the web service providers are making use of cookies to track our behaviors, okay, on the web, to track our behaviors on the web. How many different pages we visit, how many websites we visit, how much time we spend in each web page, what are all the things we buy, what are the things we order, everything they track. Okay, so this, they say they just want to improve our browsing experience. That is the reason why they make use of cookies to track our behavior. But this information has been sold in black market for some money. Okay, so now because of the privacy concerns, what some of the authorities, some of the bodies, they have made it compulsory that, am I connected? Okay, they made it compulsory that, yeah, they made it compulsory. Some of the rules and regulations, say for example GDPR, because of GDPR, they made it compulsory that every user must be given the knowledge that they have been their behavior, online behavior has been monitored by the businesses. So this information has to be passed to the every individual, because that is the reason why when you browse any of the websites, you will see a pop-up screen saying we are using cookies in this website. Okay, so you can actually go for setting up the cookies. So some of the cookies are strictly necessary cookies. Some of the cookies are functional cookies. Other cookies, you will have a collection of cookies that are enabled. What you have to do is, if you want to protect your privacy, you have to just only enable the strictly necessary cookies. Otherwise, they'll be able to track every behavior, each individual behavior of your means all the web behavior will be tracked. Okay, so that is the reason why if you are more concerned about your privacy, you need to. So if you are using WhatsApp, how many of you have enabled the security settings? You have to think about it, because you cannot keep all your data open, because someone else is benefiting from your data. So if you are more concerned about your privacy, then check for the settings. Okay, security settings. 100 terabytes of data, 100 petabytes of data, how much time it will take? You can calculate. If you can transmit 100 MB of data in 1 second, how much time it will take to transmit 1000 terabytes of data? You can calculate. Okay, so but in case of big data, we are not going to handle not only terabytes, we'll be handling petabytes, zettabytes of data. So if you are going to bring all the required data to one place and then apply the query to collect the required information, transmitting the data itself from one place to another place will take days together. Okay, maybe 10 days, 20 days, 1 month it will take to transmit the data from one place to another place according to the bandwidth availability. Okay, so after bringing the data to one place, the query will be applied and then you will be able to fetch the required information. That is the approach followed in traditional database management system. Instead, we don't want to follow such kind of approach, because transmitting big data from one place to another place is also a huge challenge. Okay, so to address these challenges, we are going to make use of a new tool called Hadoop. Okay, Hadoop is a tool which will address these challenges. Okay, these are the challenges with big data: storage, searching, sharing, transfer, analysis. All these are the challenges with big data. So in order to address all these challenges, we are going to make use of a tool called Hadoop. So Hadoop is actually a distributed framework, okay, where you'll be able to create a cluster of nodes, where you'll be able to create a cluster, Hadoop cluster, by making use of general purpose commodity hardware. You don't need to invest a huge amount in building a Hadoop cluster, okay? You don't need to invest for buying high-end servers for storing the data. You can make use of the general purpose hardware. Means you can make use of 10 laptops. You can make use of 10 desktops. Okay, you can make use of all your friends' machines. Okay, the laptop or desktop, whatever machine you have. Okay, these are all the, whatever laptop or desktop we use. They are all of not much highly they are not highly configured machines, isn't it? They are not high-end machines. They are simple for day-to-day use. We make use of, because the RAM capacity would be maximum 8 GB or 12 GB we have. Okay, and the CPU, normal CPU, which we can use it for regular purpose. Okay, so we will be using general purpose commodity hardware to build a Hadoop cluster, to build a Hadoop cluster. Okay, so who has developed this particular software? It was created by the computer scientist Joe Cutting. Okay, in 2005. Okay, it was inspired by Google's Mapreduce, a software framework in which an application is broken down into numerous small parts. Okay, so how Hadoop is going to handle big data? That is what we are going to see next. So Hadoop cluster you can create by making use of general purpose commodity hardware. Supposing I'm going to use 10 laptops to create a Hadoop cluster. Okay, I can make use of general purpose commodity hardware. That is the main beauty of Hadoop. You don't need to invest huge amount in buying high-end servers. You can make use of general purpose commodity hardware to create a Hadoop cluster. So if I'm going to make use of 10 machines to create a Hadoop cluster, I can call that as a 10 node Hadoop cluster. Okay, 10 node Hadoop cluster. So it is a open source software. It is based on Java. Okay, it is an open source software. It is based on Java that supports the processing and storage of extremely large data sets in a distributed computing environment. So Hadoop is going to follow distributed architecture. Okay, it is going to follow distributed architecture where you will be able to store the data also in a distributed manner, and also you'll be able to do the processing also in a distributed manner. Unlike traditional RDBMS systems, where we bring all the data to one place and then execute a query on the collected data. Okay, but here in case of Hadoop, we are going to do parallel processing. We are going to do parallel processing because the data has been stored across multiple nodes in the cluster. Okay, so you are going to create a Hadoop cluster consisting of 10 nodes, 100 nodes, 1000 nodes based on the requirement. Okay, so this process we call it as scaling out. Okay, this is called this. Otherwise, we call it as horizontal scaling. As and when the requirement is more. Okay, if the requirement increases, you'll be able to add more number of machines to the Hadoop cluster. Supposing if your business is a small sized business, you can have 100 machines. Suppose after 6 months your business has grown. Okay, in that case, immediately you can add 100 more nodes without disturbing the existing cluster. You can add to the existing cluster 100 more nodes. Okay, so this is what we call it as horizontal scaling. Okay, there is a limitation for vertical scaling. How much you can scale vertically means how much you can increase the capacity of a single machine. Vertical scaling means what? You are going to increase the capacity of a single machine, increasing the RAM capacity, adding more power to CPU. This is what we call it as vertical scaling, increasing the capacity of a single machine. So there is a limitation for vertical scaling according to the current technological advancements. Whatever CPU capacity that is available, processor speed that is available, only up to that we can go for vertical scaling. But horizontal scaling, there is no limit. You can add as many number of nodes as possible as required to the Hadoop cluster based on the requirement. Okay, so Hadoop is based upon horizontal scaling. Okay, you'll be able to add more number of nodes to the Hadoop cluster. Okay, and you are able to store the data in a distributed manner. You are going to store the data across all the machines in the Hadoop cluster. And also how you are going to do the processing, you'll be able to do parallel processing. You'll be able to, we are not going to bring the data to one place. Instead, we are going to send the processing logic to different nodes where the data is present. We are not going to move the data. Instead, we are going to move the processing logic. Supposing I just want to find number of employees in each department. What query you will write? Can anyone answer? How to find if you have already learned the DBMS? Tell me what is the query you will write for the command fetch number of employees in each department. I just want to count the number of, say for example, there are some 15 departments in an organization. I just want to find the number of employees in each department. What query you will write for this? Any one of you who is good in DBMS? Any one of you can answer? How many of you are there connected? Are you all listening?
Ma'am, we can use select count.
Yeah, select count. because since I just want to group the data based upon department, I can simply say select. So based upon whichever column I'm going to group the result, fetch that column also. Count of star. The table name is employee group by, because I just want to group the data based upon department name or department number, whatever it is. Okay, department name. So fetch this column also. So you will get the result like this. Result like HR 100 and 70, something like this. You will get the output like this. Okay. So this is the query you will run. Okay. So in case of traditional RDBMS system, what we will do, we will be collecting the data. We will bring all the data to one place and then apply this query on the collected data. So bringing the data, bringing large amount of data from transmitting large amount of data from one place to another place is a very difficult task. It's a challenging task whenever you deal with big data. Instead, what Hadoop is going to do is, it is going to transmit the processing logic. What is the processing logic? Processing logic is a simple query like this. So it is going to transmit how much, if you are going to store this processing logic, how much amount of space it is going to take, maybe in KBs, isn't it? This particular query will take maybe less than 1 KB of space. Okay, you are going to transmit only this query to different nodes where the data is present. Okay, transmit the processing logic to the place where the data is present, and then apply this query on the data where apply this query on the later apply this query on the data. Okay, you are not going to bring the data to one place. You are going to instead transmit the processing logic to the place where the data is present. Okay, so this query will be applied on one node. So this node 1, so you are going to create a Hadoop cluster, 10 node Hadoop cluster. Assume you have created a 10 node Hadoop cluster and you have stored the data. You have stored the data across multiple nodes in the cluster. So when I have to execute a query like this, what will happen? I have stored the data in all the 10 nodes. Okay, so what I will do, I will create 10 instances of this query and then send each instance to each node. Okay, this query will be applied on node 1. Okay, this query will be applied on node 1 and again node 2, node 3, etc. Okay, like this. This query will be applied on each node, and then the output of node 1. What will be the output of node 1? It will be a simple result, isn't it? A count of star means this will be the result. Okay, this will be the result you will get result in this fashion. Okay, transmitting the result from one place to another place is not difficult. Okay, transmitting only the result from one place to another place is not much difficult because it is again going to be a small amount of data. Okay, so what we are going to do is we are going to execute the query on each node and then collect the data, collect the result, all the result, the partial results, collect all the partial results to one place, bring all the partial results to one place, and then you will combine the results to produce the final output. Okay, you will combine the result to produce the final output. So that is how Hadoop is going to handle both storage as well as processing. So Hadoop has got two major components. Hadoop has got two major components to address the major challenges of what are the major challenges of big data. Just now I said storing and processing. These are all the two major challenges of big data, isn't it? Which the traditional database management system cannot handle. Okay, storing and processing of big data is the two major challenges. How Hadoop is going to address these two challenges is by making use of two components. Okay, the two major components of Hadoop are Hdfs and Mapreduce. The two major components of Hadoop are Hdfs and Mapreduce. What is Hdfs? Hadoop distributed file system. Okay, Hadoop distributed file system. So this will take care of, this particular file system will take care of storing the data in a distributed fashion across multiple nodes in the cluster. Okay, it will take care of storing the data in a distributed manner across all nodes in the Hadoop cluster. Okay, so this will address the storage issue of big data. What Mapreduce? Mapreduce is the processing framework. Mapreduce is the Hadoop processing framework, which will take care of which is going to perform distributed processing of the data, distributed or parallel processing. So which is going to process the data parallelly. So the major challenges of big data is storage and processing. These two challenges are addressed by the components in Hadoop. So we have a component called Hdfs, which is the file system. Okay, Hadoop distributed file system. Okay, so this will take care of storing the data in a distributed manner. Similarly, to process the data in a distributed fashion, we have a component called Mapreduce. So Hadoop is going to follow which architecture? Not the centralized architecture. It is going to follow distributed architecture. Hadoop is going to follow distributed architecture. Okay. So now when you say distributed architecture, you have the concept called master and slave. Master and slave, isn't it? When you have a distributed architecture, if you have a collection of machines, one machine will be selected as the master and the remaining machine will be treated as slaves. Okay, the master will be taking the responsibility of managing and controlling the remaining nodes in the cluster. Okay, so it is going to follow master slave architecture. It is going to follow distributed architecture. So you will have, if it is a 10 node Hadoop cluster, among these 10 nodes, one node will be chosen as the master and the remaining 9 nodes will be used as slaves. Okay, so we have some roles and responsibilities for the master node and some roles and responsibilities for the slave nodes. Okay, so we have a daemon corresponding to Hdfs. So we have a daemon called name node. Okay, so this will be running in master. This is the daemon that will be running in the master, and in Hdfs, the daemon corresponding to the daemon that is running in the slave nodes will be called as data nodes. Okay, or called as data nodes. Similarly, here in case of Mapreduce, we have a daemon that is running in the master node corresponding to Mapreduce, which is called as job tracker. Okay, that will be running in master, and the daemon that will be running in the slave nodes corresponding to Mapreduce is called as task tracker. Okay. Right. So what name node will do? Name node will store the metadata information. Name node will store metadata information. What do you mean by metadata? Anyone? What do you mean by metadata? Name node will not store the actual data. It will store the metadata. What do you mean by metadata? Any one of you?
The description of the data. Description of the data.
Yeah, very good. Very good. Description of the data. Data about data. Okay, supposing I have a file sample.txt. Inside the sample.txt, I have some content. Okay, but so when I say sample.txt, about sample.txt, what is the metadata of sample.txt? The name of the file is a metadata. Okay, what is the name of the file? Name of the file is sample.txt. And what is the size? What is the file size? File size again a metadata. Okay, file size again a metadata. What is a file type? File type is a txt file, text file. That is again a metadata. Data about data. Okay, description about data is called as metadata. So if I have a file sample.txt, the actual content of sample.txt is different. But what is the description about sample.txt? What is the file name? What is the file type? How much space it occupies in the hard disk? Okay, who is the owner of this file? When it was created? All these information we call it as metadata. Okay, so what name node does? Name node is going to maintain. Name node is a daemon that is running in the master node. Okay, so if you have a 10 node Hadoop cluster, among these 10 nodes, I'm just giving you a simple example. In reality, you will have a very big cluster, okay, consisting of 1 million nodes, 1 billion nodes, depending upon the requirement. Okay, I'm just talking about if you want to work in Hadoop tool, you'll be creating a simple Hadoop cluster. Maybe you can even create a Hadoop cluster with only 2 nodes. Out of these nodes, these 2 nodes, one you can use as master, one you can use as slave. Okay, if you want to run a small project in Hadoop, you will create a simple Hadoop cluster having only 2 nodes. Okay, so if you have a 10 node Hadoop cluster, well, among these 2 nodes, one will be chosen as the master and another one will be chosen as a slave. Okay, if you have 10 nodes, one node you will be choosing as master, and the remaining 9 nodes you will be using as slave nodes. Okay, so in the Hadoop software has got 2 major components. One is Hdfs, another one is Mapreduce. Okay, Hdfs will be taking the responsibility of storing the big data efficiently. Okay, Hdfs for storage and Mapreduce is for processing. Okay, that you have understood. And also you have understood that Hadoop is following distributed architecture, which means it is going to follow master-slave architecture. So if you have a 10 node Hadoop cluster, one node you will be choosing as master and the remaining nodes will act as slaves. Okay, so in Hdfs, which will be taking care of the storage part, there is a daemon called name node that will be running in master node. Okay, this is a daemon that is corresponding to Hdfs, which is running in master. Okay, so this node will not actually store the data. This node will not actually store the data. This will store metadata. This will store data about data. Okay, which means supposing I just want to store a file called sample.txt in Hdfs. I just want to store a file called sample.txt in Hdfs. What it will do? So it is going to provide you, Hdfs is going to ensure it is going to provide you reliable storage. Okay, reliable storage. Okay, which means it is going to ensure that supposing if a node fails, okay, if a node fails, you will not have, you should not lose access to data. If a node fails, supposing I have stored a data, I have stored a file sample.txt. This sample.txt file is stored in different nodes. I have N1, N2, N3, etc. up to N10. Okay, among these nodes, N1 is the master node and the remaining nodes are slave nodes. Okay, I'm going to store this data in this cluster, 10 node Hadoop cluster. What name node will do is it is not going to store the data sample.txt as such in only one node. It is not going to choose sample.txt. It is not going to store sample.txt in only one node. What will happen if it is going to store the entire file in one node? Okay, the first problem is maybe this file is of huge size. The capacity, RAM capacity or hard disk capacity of this particular node may not be sufficient to store such a large file. Okay, that is one challenge. That is the reason why we are using Hadoop, isn't it? Because we are going to talk about big data. Okay, so what Hdfs will do is it is going to divide the data into multiple blocks. Okay, it is going to divide the data into multiple blocks and then it is going to store these blocks in different nodes. Okay, it is going to divide the data into multiple blocks. So the default block size is 128 MB. The default block size is 128 MB. So if I'm going to store a file, inside Hdfs, assuming the file sizes, I'm just talking about a small file, but Hdfs is not suitable for smaller files. It is suitable for large sized files. Since we are talking about big data, in practice, we'll be storing a large file inside Hdfs. So for the sake of explaining the concept, I'm using a file named sample.txt and the file size is 500 MB, assume. Okay, so what Hdfs is going to do? It is going to divide the file into a number of blocks and each block will be of size 128 MB. So now tell me how many blocks will get created from this text file. How many blocks will get created?
4.
4 blocks.
4 blocks. Okay. The first 3 blocks will be of size 128 MB, and the last block will be of lesser size. Okay. So 128 plus 128, 256. Okay. And third block is also 128. Okay. The last block may be of size lesser than 128. Okay. So there will be a set of 4 blocks because the default block size is 128 MB. So it is going to create 4 blocks, and it is going to store, Hdfs is going to store these 4 blocks in different nodes. These 4 blocks in different nodes. So name node will be taking the responsibility of dividing the given file into a number of blocks. Okay. And then it also will take the responsibility of identifying the nodes where these 4 blocks can be stored. Okay. So depending upon the availability of the resources, where the resources are available. Okay. Resources in the sense, since I'm going to store the data, the main resources, hard disk. Okay. Okay, where the resources are available, you just want to identify the machines where it can store these 4 blocks. Okay, each block will be stored in different. Maybe it is going to store node 3, node 5, and node 7, depending upon the availability of the resources. Okay, so it is going to choose different nodes for storing the blocks. Okay, so in N2, it is storing block 1. In N5, it is storing block 2. In N7, it is storing block 3. In N8, it is storing block 4. Okay, assume. Supposing node 5 fails. So I have created a Hadoop cluster. There is a possibility. We cannot expect that all the nodes will be up and running all the time, isn't it? There can be failures, isn't it? Some nodes may fail. In that case, what will happen? I have stored block 2 in node 5. If I have to do some processing on sample.txt file, I will not be able to do the processing now because the block 2 is present in node 5, which has failed. Node 5 has failed, and I have stored block 2 in node 5. Block 2 corresponding to sample.txt in node 5. Okay. So what will happen if such kind of failures are encountered? We need to address this, isn't it? So what Hdfs will do? It is going to apply the concept called replication. It will not store each block in only one machine. It is going to store each block in 3 different nodes. So the default replication factor is 3. Okay, it is again configurable. If you want to ensure more availability, high availability, if you want to ensure high availability, then you can go for a replication factor is 5 or 7. Okay. Supposing if you don't want to have high availability, then you can reduce the replication factor as 1 or 2. Okay, so the default replication factor is 3. So you will have 3 replicas for each block. Okay, so what name node will do? It will identify 3 nodes to store each block of data. It will identify 3 nodes for storing each block of data. Okay, so that is how it is going to ensure high availability of the data. Understood? So what name node does? Name node is not actually going to store the data. It is going to store the metadata. So what are the metadata here? Can anyone tell me? What are the metadata related to storing the file sample.txt? Name of the file, actual file size, how many blocks are corresponding to this file, and where each block is stored. Okay, where each block is stored, and where are the replicas are present for each block. Okay, so if there are 4 blocks, block 1 is available in node 2, 3, 4, 5, and block 2 is available in node 5, 6, 7, something like that. Okay, so it is going to maintain metadata information. Name node is going to maintain metadata information about each file, where how many blocks are corresponding to this file, where each blocks are stored. So that is the information that will be maintained by name node. Okay, and in the slave nodes will actually store the data. Okay, that it will store the actual blocks. So these are all the slave nodes. These are all the slave nodes in which we are actually storing the data. Okay, the blocks are actually stored in these slave nodes. Understood? What is the meaning of name node? What is the meaning of slave nodes? Okay, the data nodes. Okay, data node is the daemon which is actually the slave node, which will be storing the actual data. Name node will store the metadata. Okay. So these are all the daemons corresponding to Hdfs. Name node and data node are the daemons corresponding to Hdfs. Name node will be running in master. Slave node, data node will be running in slave nodes. Data node daemon will be running in slave nodes. Similarly, in Mapreduce, we have two daemons. Okay, which is job tracker, which will be running in master, and task tracker will be running in slave nodes. Okay. So what job tracker will do if a job arrives, if a processing job arrives? One example I gave is finding out the number of employees in each department. So for which I will be writing a Mapreduce code. Okay. We have seen initially itself, Hadoop is based upon Java. So you'll be using Java to write Mapreduce code. Okay. So you will be executing this Mapreduce job. So whenever you want to execute a new job, the client will contact the job tracker. So job tracker will be taking the responsibility of identifying how many, because it is going to perform parallel processing of the data, isn't it? It is going to perform parallel processing. So we have 4 blocks corresponding to the file sample.txt. We have 4 blocks corresponding to the file sample.txt. And these 4 blocks are stored in multiple nodes. Okay, depending upon the replication factor, it is stored in different nodes. So what Mapreduce will do, in Mapreduce, we have the job tracker daemon running in master node. So this master node will identify where are the blocks, okay, from which of the nodes the blocks B1, B2, B3, B4 are to be fetched. Okay, it will choose the nodes from where these blocks are to be fetched corresponding to the file sample.txt. Okay, and then if there are 4 blocks, it will deploy 4 mappers. Okay, it will deploy 4 mappers. Each mapper is a processing logic. Okay, mapper is the processing logic, which will you will include the logic to process the data in such a way that so that you will be able to fetch the final output. Okay, so as a programmer, as a Mapreduce programmer, you have to decide on the logic. You have to decide on what should be the mapper logic, what should be the reducer logic, so that ultimately I get this output. Okay, so what this job tracker will do, it will identify how many mappers are required. So one mapper will be corresponding to 1 block of data. Okay, if there are 4 blocks corresponding to this file, input file, it will deploy 4 mappers, because we are not going to bring the data to one place. Instead, what we are going to do in case of Hadoop, we are going to transfer the processing logic to the place where data is present, isn't it? That is the beauty of Hadoop. We are not going to bring the data to one place and then apply the processing logic. That is the traditional way of processing the data in RDBMS. But in case of Hadoop, what we are going to do, we are going to transmit the processing logic to the place where the data is present. Okay, so in that case, we are going to transfer how many mapper logic depending upon the number of blocks. Okay, so if this is the input file, this input file, yeah. Could you please mute yourself, participants? Okay, so corresponding to the file sample.txt, there are 4 blocks. Okay, so therefore, what job tracker will do, it will deploy 4 mappers, so that each mapper will process 1 block of data. Each mapper will process 1 block of data and will fetch the intermediate result. Okay, so the actual processing will be done in task tracker. Task tracker will be taking care of fetching the required resources for performing the processing. Okay, required resources in the sense CPU time, RAM memory, all are the resources that are required to run any job, isn't it? You need the CPU time, you need the RAM capacity, because any running application will take space in RAM, isn't it? Any running application will occupy the space in RAM. So task tracker will be taking the responsibility of running the mapper on the available data. Okay, task tracker will be running on the slave node. So the slave node actually holds the data. So task tracker will apply the mapper logic on the current data and will fetch the intermediate result. Okay, so that is how it is going to work. Now let me take you back to the slides so that you will be able to understand. So you will see the Hadoop architecture like this. You have Hdfs, you have Mapreduce, and in the Hadoop version 2, initially in Hadoop version 1, Mapreduce was the only component that was taking care of both management as well as processing. Okay, but later they have introduced another new component called Yarn. Okay, Yarn will be taking care of resource management. Yarn will be earlier in Hadoop version 1, Mapreduce was taking care of both processing as well as resource management. Okay, both processing as well as resource management. But later they introduced in Hadoop version 2, they have introduced another component called Yarn, yet another resource negotiator. Meaning of Yarn is yet another resource negotiator. So this component was introduced in Hadoop version 2. So because of this new component, Mapreduce was relieved from the responsibility of resource management. It will take care of only processing, and Yarn will be taking care of resource management. Okay, so these are all the Hadoop common libraries. Okay, so Hadoop is based upon Java. So in order to execute a Mapreduce job, you need some libraries. Okay, so those libraries will be under this commons. Okay, Hadoop common library. It's a collection of common utilities and libraries that support other Hadoop modules. Okay, Yarn is yet another resource negotiator. It is a resource management platform responsible for managing computing resources in clusters and using them for scheduling of users. So this is Hdfs, Hadoop Distributed File System. So you will have this will be running on the existing file system. Means you will have a physical file system, isn't it? Supposing if I'm using Windows operating system or Linux operating system or Mac OS, depending upon the operating system that I use, that is a physical operating system that I have. On top of it, I will have the virtual operating system in which Hadoop is running. Okay, so Hadoop will be making use of will be running on top of the existing file system. Okay. So it will be actually, it is designed to handle very large files with streaming data access patterns. So Hadoop is suitable for very large files. It is not suitable for smaller files. It is suitable for larger files because you are going to divide the data into multiple blocks and store the data across, store the blocks across multiple nodes in the cluster. So if you have a data, input data, it will get divided into number of blocks and each block will be stored in different machines. Okay, uses blocks to store a file or parts of a file. So now if you see here in Hadoop version 1, the default block size is 64 MB. In Hadoop version 2, the default block size is 128 MB. Again, it is configurable. If you want to configure it to be 256 or 512, you can go and configure, not a problem. Okay. So one Hdfs block is supported by multiple operating systems. So you see here, so because the physical OS is different. Okay, Hdfs is running on top of the physical OS. Fits well with replication to provide fault tolerance and availability. So why we are going for replication? To ensure high availability of the data. Okay, can you know the audience? They are in first year of engineering or second year or the mixed group. Can you tell me, Divya? So that I will be noting.
We have from all batches, ma'am. Like from first to final year, we have every students.
Okay, okay. Because some of the concepts they may not have exposure. That is it.
Yeah. Yes, ma'am.
Okay, no issues. So some of you may not be knowing what is physical operating system, what is virtual OS. Okay, virtualization. You don't have heard about virtualization. If you don't know what is the cloud computing concepts under which you will be talking about physical OS and virtual OS. Even for cybersecurity courses, you would have installed virtual OS on top of your physical OS, okay, where you will install some of the software. So here we will be installing, if you want to install Hadoop in your machine, you have to follow a sequence of steps. Okay, so those are interested, I can share the material if you are interested to install Hadoop. Okay, otherwise you can make use of the cloud Hadoop installation. Okay, you can make use of the cloud setup. Okay, where you need to buy the cloud lab access to execute your Hadoop Mapreduce job. Not only Hadoop, in Hadoop ecosystem, we have a collection of tools like Hive, HBase, Pig, Spark. These are all the tools that are available in Hadoop ecosystem. Okay, based upon each one is going to serve one specific purpose. Okay, so if you want to perform real-time, Hadoop is suitable for batch processing, whereas we have another tool called Spark, which is suitable for real-time analytics of data. So if you want to process the data in real time, Hadoop is not suitable for that, so that we go for Spark, which is as tool available in Hadoop ecosystem. Okay, so for each of these tools, if you want to work work on a project using these tools, instead of installing them, you can go and install in your machine, but there are some hardware requirements. Minimum 12 GB RAM is required. You can install the virtual machine. On top of it, you can install Hadoop by following the installation procedure. But instead, if you want to use a Cloud Lab setup, then you can buy. I'm using CloudX Lab. Okay, this particular platform is giving access to CloudX Lab, is giving access to all the Hadoop ecosystem tools. Okay, so they are charging some $18. Okay, those who want to work in Hadoop, you can use that. Okay, I'm going to show you the demo on that. So I think the theory part is enough. I'll just go and talk about how you can write a Mapreduce code for a simple problem. Okay, so I spoke about replication. Blocks with data replicated to multiple nodes allows for node failure without data loss. So if you see here, the client wants to write a file. It wants to store a file in Hdfs. So what will happen? The file will get divided into number of blocks, and it is going to store each block in different machines. Okay, based upon the replication factor. The replication factor is 3. It is going to store the data in 3 each. It is going to store each block in 3 machines. Okay, how it is going to choose the nodes depending upon a concept called rack awareness. So if you see a data center, the machines are arranged in this order. Okay, each rack will contain multiple machines. Okay, so how many of you? Some of you might have visited a data center in which the machines are arranged in racks like this. Okay, rack 1, rack 2, rack 3. So how the nodes are chosen to store the blocks is based upon a concept called rack awareness. So if you want to, you have to understand a concept called inter-rack communication and intra-rack communication, which means if these 2 machines are in single rack.
Ma'am, sorry to interrupt. You are muted.
Yes, ma'am, you got muted now.
I'm sorry. I think the organizer might have muted all. Okay, no issues. I was talking about inter-rack communication and intra-rack communication. Okay. So what is inter-rack communication? Communication that takes place between one rack to another rack. Okay. So I have node 2 in rack 1, node 3 in rack 2. So if there is going to be communication between node 2 to this node 3, this communication we call it as inter-rack. Okay. If node 2 here communicates with node 3 in the same rack, that we call it as intra-rack. Okay, the cost of intra-rack communication is lesser than inter-rack communication. So whenever the name node wants to identify the nodes where the blocks are to be replicated, it will try to reduce the number of inter-rack communication. This concept we call it as rack awareness. Okay, so it will choose the nodes to create replicas in order to, with the objective to reduce the number of inter-rack communications. Okay, so that is how it will store. So you have 3 blocks corresponding to file 1. So name node will take the responsibility of identifying the nodes, so that with the objective of reducing the number of inter-rack communication. So B1 will be stored here, B1 will be stored in another rack, and in the same rack, B1 will be stored in different node. So this is how. So this concept we call it as in rack awareness. Okay. So we don't want to, if the replication factor is 3, we don't want to store the third copy of B1 in different rack. Okay. So we will be trying to store 2 blocks, 2 copies, 2 replicas of the same block in the same rack. Okay. 2 replicas of the same block in the same rack, so that we reduce the number of inter-rack communication. Okay, that is the objective. Right. Also spoke about Mapreduce. It's the heart of Hadoop because it is a processing framework that allows for massive scalability across hundreds or thousands of servers. So I spoke a lot about Mapreduce. So this actually Mapreduce comes from functional programming concepts. Some of you must have learned what is functional programming. Functional programming has one of the features of functional programming is it supports higher order functions. What do you mean by higher order functions? We would have created, written some functions, isn't it? In any of the languages, C or C++ or Java, okay, where we will pass some arguments. These arguments may be of type integer or float or string or characters, or sometimes it may be a pointer, something like that. If a function is going to take another function as input, okay, if a function is taking another function as input, such kind of functions we call it as higher order functions. Okay, so map is a higher order function which takes another function as input. Okay, so map is a higher order function that applies a given function, the input function, to each element of a list. Okay, so map is a higher order function which takes another function as input, and it is going to apply that function on each element of the given list. And reduce is also a higher order function which is going to take another function as input and will analyze the recursive data structure and recombine through use of a given combining operation. So in simple terms, what reduce will do is going to apply an aggregated function on the intermediate result to fetch the final output. Okay, I'm going to demonstrate this. I'm going to demonstrate this in terms of a simple example. Let's see. Okay, so as I already explained to you, it is going to follow master-slave architecture. So you will have one node deputed as master and the remaining nodes as slaves. Okay, so you have the daemons. The daemons that is running in master will be name node. Name node will be corresponding to which component? Name node is corresponding to which component? What are the two major components of Hadoop? Hdfs and Mapreduce, isn't it? Hdfs will be taking care of what? Hdfs is for storage, Mapreduce is for processing. Okay, so in the master node, there will be two daemons running. The name node corresponding to Hdfs and job tracker corresponding to Mapreduce. Similarly, another two daemons will be running in all the slave nodes. Data node is a daemon corresponding to Hdfs and task tracker is a daemon corresponding to Mapreduce. Okay, so this is how the architecture will look like. Okay, so let's see how the theory I'll explain with a simple example. So whenever we just want to run a Mapreduce job, I'm going to take the example of a word count problem. I'm going to take the example of a word count problem so that you'll be able to understand. Supposing I have a file, text file, in which, so this is the file, text file, sample.txt. I have some content like this. I just want to count the number of words. I just want to count the number of occurrences of each word. Number of occurrences of each word. How many times the word first occurs, how many times the word is occurs, how many times the word teaching occurs. So like that, I want to make a word count. Okay, for this, I'll have to write a code, Java-based code. Okay, so if I'm going to write a Mapreduce job, you have to understand first of all, in case of Mapreduce, how the okay, so if I'm going to run a Mapreduce job, first of all, you have to understand the input-output format of mapper and reducer. So I have to write a mapper logic, and later I have to write a reducer logic. Okay, to solve the problem. So what is the problem here? Word count, number of occurrences of each word in the given input. Okay, number of occurrences of each word in the given input. That is the problem. Okay, so I have to find a logic so that ultimately what I have to do, this is the input file. If this is the input file, it has to tell me how many times the word this occurs, how many times the word is occurs. So like that, number of occurrences of each word should be the final output. Okay, so for that I have to write some logic. So what mapper will do, mapper will take the input. So you have to understand first of all what is the input output format of each of these phases. So Mapreduce will follow a sequence of phases. Mapper is the first phase, okay, and the intermediate phase is shuffle and sort. Shuffle and sort is the intermediate phase. This phase will happen automatically. You don't need to write the code for this. Okay, and the final phase is reducer. Reducer also, you have to, for reducer also, you have to write the logic. Okay, how you have to combine the intermediate results. You have to apply some aggregation in order to fetch the final output. Okay, what is the input format for mapper? Input format for mapper is key value pair. Key value pair. Okay, input format is key value pair. What is key? Key is the line number. Key is the line number because it is going to process. Mapper is going to process one line at a time, one input line at a time. Okay, mapper is going to process one input line at a time. Okay, key is the line number and value is the actual line. Value is the actual line of input. Value is the actual line of input. And it is going to produce the output. Output also in the format of key value pair. Mapper will produce the output in the format of key value pair. Okay, what is key? What is value here? Key is again it is problem specific. Okay, problem specific depending upon the problem. So if it is a word count problem, you have to identify what should be the, so what output I want? Output that I want is each word plus count. Okay, this is the output I want. Okay, for each word, what is the count? That is the output I want, isn't it? That is the output I want. For each word, supposing if I have the word, high, how many times it is there? It is there only one time. So the output should be, is going to treat this as one word. Output is 1. Okay, and the word this, how many times it is present? It is also present only one time. Okay, is this present how many times? Here 1, here 1, 2 times. Okay, is this present 2 times? Like that for each word, the number of occurrences it has to display. That is the final output I want. I want the output in this format. Okay, so for this problem, the output should be word and then count. Okay, so for mapper, the output is in the format of key value pair. So what is key here? For this problem, the key is word and the value is the count. Value is the number of occurrences of that word. Count how many times? Okay, value is count. Mapper will not do any aggregation at all. Mapper will read one line of input. Okay, each time mapper will read one line of input and then it is going to produce this output. Okay, so what mapper will do, initially it will read this line. Okay, and then will segregate this line into individual words. So first line contains only one word. Okay, so it is going to produce this word as output and the count as 1. Second line it will take, if you see here, this line contains number of words. Okay, so it is going to divide this line into individual words based upon the delimiter. How the words are separated here, the delimiter here is space, blank space. So this is one word, is another word, first is another word, class is another word. So it is going to divide the given line into number of words and then it is going to produce the output as this one. Okay, is 1. Like that, it will not do any aggregation at all. It will just segregate the word, put the count as 1. Segregate the word, put the count as 1. That is what mapper is going to do. So for each line of input, it is going to identify the It is going to identify the individual words and then put the count as 1. That is what mapper will do. So key is word, value is count. So at the mapper level, count is always 1. It will not do any aggregation. Okay, it will not do any aggregation. Okay, and then what shuffle and sort will do, because since we are going to run this mapper logic on different blocks, since we are going to run the mapper logic in different blocks, sort and shuffle, say for example, we have considered a smaller file, assume it has created some 4 blocks out of this. Okay, this is hypothetical scenario. This is block 1, this is block 2, this is block 2, but actual block size is 128 MB. This is block 3. This is block 3. This is block 4. Okay, this is block 5. Assume. But in reality, one block is 128 MB. But for the sake of explanation, I'm just saying there are 5 blocks. Okay, each mapper is going to process 1 block of data. Okay. Okay, and supposing this is both these 2 lines together 1 block. Assume these 2 lines together 1 block. Okay. This is also block 1. This is block 2. Block 3. Block 4. Okay. So if there are more lines of input in each block, what it will do? Mapper will process 1 line at a time. Okay. So initially it will process. This block contains 2 lines. Okay. So it is going to process the first line and then it will produce the output as in the format of key value pair. It is going to process the output in the format of key value pair. So it is simply say output the word and put the count as 1. Again, it will process the next line. Okay, so like this, we're going to segregate each word and put the count as 1. That is going to be the output for each mapper. So how many mappers will be there according to the given example? I said 1 mapper will be deployed for each block of input. So how many blocks we have created here for the file sample.txt? According to the hypothetical explanation, how many blocks we will have here? How many blocks you have shown here? 4 blocks, isn't it? So how many mappers we need? We need 1 mapper for each block. Therefore, how many mappers we need here? We need 4 mappers because we need 1 mapper for each block. Okay, right? So what mapper will do? It is going to read 1 line at a time and will treat each line of input. Okay, in the format of key value pair, where key is the line number. Line number is of no significance. We are not going to process a line number, and the value is the actual line of input. Okay, so we are going to read 1 line at a time, and then we'll produce the output in the format of key value pair. Input is also key value. Input is also key value. Output is also key value. What is input key value? Input key value is input key is line number. Output key is actual line. Okay, so sorry. Input key is line number. Input value is actual line. Output key is what? It is problem dependent. Okay, for the word count problem, output key is the word and output value is for the mapper. It is always 1. The occurrence of each word is 1. As and when it encounters a word, it is going to put the count as 1. So what shuffle and sort will do? It is going to combine the intermediate results from different mappers. Okay, it is going to combine the intermediate results from different mappers. So this is the output from it. This is the output from mapper 1. This is the output from mapper 1. So we will get the output from like this. We will get the output from mapper 2. Mapper 2 will work on this block. Okay, so it is going to have the output as I1, love 1, teaching 1. Like that, it is going to produce the output. Okay, from mapper 2. Similarly, mapper 3 will work on block 3. So learning is 1, is 1, and fun 1. Okay, like this it is going to produce out. Now if you see here in output of mapper 1 also contains a word is. Mapper 3 also contains a word is. Okay, so now what shuffle and sort will do? It is going to combine the results of the intermediate results generated by each mapper. Okay, it is going to shuffle and then it is going to sort the result in alphabetical order. So the input format for shuffle and sort is key value. Key value. Okay. That is the input. Input is key value. Format of key value. Output will be in the format of key comma list of values. Key comma list of values. Okay, that is the output format for shuffle and sort. So what will happen is it is going to shuffle the results from each mapper, and it is going to generate for each key. If the key matches, supposing for the example for this is the key is two different mappers, isn't it? The key, we have the same key in M1 also as well as in M3 also. Okay. For the other words, the count is same. Okay. No problem. So what it will do for the other words, it is going to generate the same word and the output as 1. But for the word is, because that is according to this example, only the word is getting repeated. Okay. So therefore, what it will do for the word is, it's going to generate a list of values 1, 1, 1, supposing if there is one more line. If there is one more line like this. Something like this. Okay, I have a repeated set of words. If I have a repeated set of words, okay, something like this. We have a repeated set of words. So what it will do is, if the key matches, it is going to combine the results. It is going to combine the result like this. It's a list of words. It's a list of words. Sorry, list of the count of values. Okay. So the output format is for the word is, it is appearing in different. It is this word. This key is part of different mappers. Therefore, it is going to combine the values like this. Okay, it is going to combine the values like this. Key comma list of values. The input format for shuffle and sort. You don't need to write the logic for this. This will happen automatically. Okay. And finally, the input for reducer is, it is going to take the input from the output of shuffle and sort. Output of shuffle and sort is this. Therefore, input for reducer is key comma list of values. Key comma list of values. On output is key value. Output is. So what it will do? You have to write the logic for this. Supposing I have the input in this format. What aggregation I want to do here according to the given problem? I want to find the number of occurrences of each word. Therefore, I have to add these values, isn't it? I have to add these values. So I have to produce the output as is comma 3. The word is appears 3 times. That is how I have to produce the output. So the aggregation depending upon the problem. So this is a word count problem. Supposing if I want to find out the total salary payable. The total salary payable in each department. Total salary payable in each department. Total salary payable in each department. Okay, something like this. Okay, so here the department HR from one mapper. From one mapper, the output is like this. From one mapper, output of mapper 1 is HR 25 L. Okay, okay, and finance L. Okay, and IT 22L, something like this. You have this is the output of mapper 1. Similarly, you have output of mapper 2 as HR, because each mapper is going to process one block of data. Okay, 22L. IT like this. Okay. So when sort and shuffle combines the results, it is going to combine the results in the format of based upon the key. The key matches, it is going to combine the result. For HR, the list of values are 25L, comma, the key matches, okay, 52L. Okay. And for finance, there are two, I have assumed only 2 blocks. The values are like this. Okay, finance, I find only one output from all the mappers. Therefore, it is only list of one value, Okay, and for IT, it is 22L, comma, 56L. Okay, like this. So you have the output like this. Output of sort and shuffle like this. So for this problem, when I write the reducer logic, what you will do in case of word count problem, I've added the individual values like this. Okay, so to find the total number of occurrences of the word is, I will add these values. Similarly, in case of finding the total salary payable in each department, what the reducer will have to do, what aggregation it has to apply. Again, it has to apply some of these values. For each key, it has to add the values, isn't it? Sometimes I may have to find the highest paid employee in each department. Highest paid employee in each department. In that case, I'll fetch the salary of each employee, and then finally I'll find the maximum value out of it. So there the aggregation is finding the max value among the list of values. Supposing another question is identify the lowest paid employee. Okay, in that case the aggregation would be finding out the least value, the lowest value. Okay, so depending upon the problem statement, the type of aggregation you want to do is, because you have a list of values as the output from the sort and shuffle phase. Okay, so depending upon the problem, the aggregation that you do may be different. Sometimes you you want to find out the sum. Sometimes you want to find out the max value. Sometimes, because the possible aggregation task would be, what are the possible aggregation tasks? Min, max, sum, count, average. All these are aggregation tasks, isn't it? Sometimes you want to find the average salary paid. Okay, these are all aggregations you can perform. Usually, reducer performs the aggregation. So depending upon the problem statement, you have to write the logic for finding the aggregation based upon the output of from the output of sort and shuffle. You want to apply a suitable aggregation to get the final output. Okay, that is how it works. So input for reducer is key comma list of values. Output is key comma value. So you will have the output like this. Okay, this is one example. So what I'm going to do is I'm going to show you now how to write the code for this. How much time I have, Divya?
Ma'am, no restriction, ma'am. You can take as long as you wish.
Okay, so see this simple example. I have a file, input file like this, and the words are like this. Okay, content of this file is like this. So for the sake of explaining, again, they have splitted the input file into 3 blocks. The first block contains this, second block contains this, and third block contains this. So if we have 3 blocks of data, how many mappers we need? Any of you? If we have 3 blocks of data, how many mappers we need?
3 mappers.
Very good. So if we have 3 blocks of data, number of mappers is equal to the number of blocks or number of splits. Okay, so if we have 3 splits or 3 blocks, we need 3 mappers. Okay, so now we are going to deploy 3 mappers, so that what is the need for multiple mappers here? We want to do parallel processing because we are talking about big data. So we don't want to process one data at a time. We just want to process all the blocks of data at the same time. Okay, therefore the mappers will be running on individual machines, individual nodes on the individual block of data. Okay, so one mapper is going to process this data. So what is the task here? Mapper, we need to write the logic. The logic is the problem is to find the word count. So divide the given line of input into individual words and then find the count. So at this time, I don't want to do any aggregation. So just to say segregate the word, put the count as 1. Segregate the word, put the count as 1. Deer 1, bear 1, river 1. So even though in this line of input, I have the same word appearing twice, but still I won't do the aggregation saying car, 2. Simply the mapper will divide the given line of input into individual words and put the count as 1. That's it. Car, 1, car, 1. Okay. Even though I have the same word appearing twice, I will not do the aggregation saying car, 2 here because mapper will not do aggregation at all. Okay. It is not the responsibility of the mapper to do the aggregation. Okay. It will simply split the word, put the count as 1. Okay. Understood? Similarly, deer, car, bear, put the count. Now what shuffle and sort will do? It is going to shuffle based upon key. It is going to group the data based upon key. If the key matches, bring it to one group. So bear. So am I there? Connected? Can you listen to me?
Yes, ma'am. Yes, ma'am.
Okay. Right. So if you see here, shuffle will group the data according to the key. If the key matches, it brings it here. Okay. So what it will do? Bear 1, 1. Okay. For the same key bear, it is going to produce a result as 1, 1. Car 1, 1, 1. Deer 1, 1. River 1, 1. So the output of shuffle and see it is arranged in alphabetical order. That is the reason why I said it is shuffle and sort because the results will be arranged in alphabetical order. Okay. So bear, 1, 1. Okay. List of values. Car 1, 1, 1. List of values. Okay. So it is going to produce the output in the format of key, list of values. So what reducer will do? Will do the aggregation depending upon the problem. Now the problem is to find the count. So that we'll find the sum of these 1 plus 1, 1 plus 1 plus 1, again 1 plus 1. Okay, so final result is something like that. Understood how Mapreduce works? So that is what we are going to see in this code also. So now I'll be asking you some quick questions. Please unmute yourself and speak. Okay, so what is the input-output format for mapper? What is the input-output format for mapper? Any of you?
Input key value, key line number value.
Yeah, input is key, value. Output is also key, value. But what
Yes,
is
key,
what is key in input? What is input key? Input key is line number, which we will not process. Input value is the actual line of input. Okay, so if you see here, I am writing a Mapreduce code for. So I'll be using. We need to have some libraries. Hadoop common library we have to import. So I'm using Eclipse IDE for writing this code. So the package I have included, name of the package is MyPack. And all these packages I have to import. Okay. So these packages are required to run a Mapreduce job. Okay. So now I'm defining a class word count. Okay. In which I define two classes, two subclasses. Okay. Under word count class, I define two subclasses. My mapper, which extends the superclass mapper. And if you see the signature of mapper, the first argument is of type long writable because I told you the input key is line number. Since we are talking about big data, each block of data will be containing many number of lines, isn't it? So that is the reason why I'm not using int writable. Int means we can handle only small number of values. Since we will have many number of lines of input, I use the line number is going to be of type long writable. These are all the data types specific to Hadoop. But in general Java, we have int, float, string, character, all these are the data types we use in Java. But we have specific data types in Hadoop. Okay, long writable, text is something similar to string. Okay, so I told you the first the input key is line number, input value is actual line. So this actual line of input we are going to treat it as text. And then what is the output format? Output format is again key value, which is problem specific. So what is the output key for word count problem? For word count problem, the output key is, for word count problem, the output key is, what is the output key in mapper? The actual word. Okay, the actual word, and output value is count. Okay, so that is the reason why we say here output key is text. From mapper, the output key is text, and the output value is int writable. Means it is a simple integer value. Okay, and similarly, the reducer, if you see here, it extends the superclass reducer. What is input output format for reducer? Input key is,
Comma list of values for input.
yeah, key comma list of values. Okay, so key is the actual word, therefore it is text, and list of values. What kind of list of values? What type of list it is? It is a list of integer values, isn't it? It is a list of integer values. List of integer values. So that is the reason why we say here int writable. Int writable. Okay. And then what is the output format? Output format is also
Comma value.
key, yeah, key comma value. It is key is text, value is int writable. Okay. Now, and then we define the main function. Now let me expand this and show you the mapper logic. So inside my mapper class, I'm defining a map method. I'm overriding in the sense map is a method already defined. I just want to override it. I just want to give a new definition for map method according to the problem in my hand. Okay. So what mapper will do? It is going to process. I will have to write the logic only for one line of input. So that what mapper will do will process one line at a time. Okay. So supposing if the given block contains 1000 lines, this mapper logic will run for 1000 times. Okay. So because this logic will run for one line of input. Okay. So I'm going to write the logic for processing one line of input. So I'll take one line of input. So that I call it as, it is available in the variable name. What is it? Where is it? In IP value, because this is not important. Input key is not important. I'm not going to do anything with the line number. I'm interested only in the actual line of input. Actual line of input is available in the variable name IP value, input value. Okay, so what I do, I convert this line of input into string because it is in the format of text. Convert that into string. Okay, and call it as line. And then I use a tokenizer method, tokenizer class, string tokenizer class to tokenize, means to segregate the individual words from the given line based upon the delimiter. The delimiter here is blank space. I have a line of input. So in this line, I have multiple words. These words are separated by blank space. Therefore, what I do, I specify the input line, means the variable contains an actual line of input, and then segregate that, find out the individual tokens. Individual tokens in the sense, each individual word. Each individual word will be available. It will be segregated and will be put under the variable name tokenizer. Now I check how many words are there. Okay, for each word. So I'm using this looping structure to process each individual word. So what I'm going to do is fetch each individual word and then set. Supposing if this is the line of input, okay, and this I divide. So IP value will be representing this line at this time. And I'm going to use a string tokenizer method to segregate the individual words. And once I've segregated the individual words, for each word, I'm going to give the output as join, comma 1, me, comma 1, in, comma 1, having, comma 1, hands on, comma 1, something like that. Okay, so output key is tokenizer.next token. So it actually gives you the actual word. Okay, actual word, and then put the count as 1. And I'm going to print the output as output key. Output key is the actual word, and then the value is integer value 1. But since we have mentioned the output value of type int writable, which is a Hadoop data type, I just want to convert this pure integer value into an object of the class int writable. An object of the class int writable. Therefore, I say new int writable count. Therefore, this pure integer value will be converted into an object of int writable. Okay, object of the class int writable. Okay, so that is what I'm giving us output. So what is context here? This context is going to give us a context to write the output. Okay. So now I just say context.write output key and output value. Okay. Output value is 1, which is actually a pure integer value here. But I want to convert that into an object of type int writable. Okay. So that is what I'm doing here and then printing. So this code will get executed for each line of input. So finally I'll get word comma count as 1, word comma count as 1 for each word. Okay, that will be the mapper output for. That is the output generated for each line of input in the given block. Okay, so once that is done, shuffle and sort will happen automatically. You don't need to write the code for that. And then you will have to write the logic for the reducer. What reducer will do? Reducer is taking the input. Reducer is taking the input in the format of key comma list of values. See here, iterable, int writable. Why? Because it is a list of values. Okay, because it is getting the reducer is getting the input from where? From where reducer is getting the input?
Shuffle and sort.
Shuffle and sort. Reducer is getting the input from shuffle and sort. And if you see the output of shuffle and sort, it is in the format of key comma list of values. Key comma list of values. That is what is indicated here as iterable, int writable. It is the list of values of what type? It is the list of values of int writable type. Okay. And then again you have this, you need this context for writing the output. Okay. Now what I do, I have to do the aggregation. So I initialize variable sum, initialize to 0. And then what I do, I just process fetch one value. So values is a variable containing list of values. Okay, therefore I just want to process one value at a time, get each value and add it to sum, because it is in the format of, it will be like of list of 1, 1, 1, like this, etc. Okay, like this. So fetch one value at a time, add it to sum. Next time fetch this, add it to sum. Third time fetch this, add it to sum. So finally sum will have the value 4. Understood how it works? Each time I'm going to fetch one value from this list, add it to sum. Therefore finally I'll get, for the given key, I'll be able to find the total number of occurrences. Okay. And finally we need to define the main method. In main method we need to set up the configuration and then specify what is the instance. So instance here is the name of the class, name of the main class, name of the class where the main method is present. So name of the class where main method is present is word count. And then you have to specify the input output class. So input map, for the mapper, the class name is my mapper. You see here, for the mapper, the class name is my mapper. For the reducer, the class name is my reducer. Therefore say my mapper.class, my reducer.class. And what is the output key? Output key is text, because for the word count problem, output is word and the count, isn't it? So output key is text.class. Output value is int writable.class. And input format classes. What type of input file you are going to pass? I'm going to pass the input file as sample.txt. That is my input file. Therefore, the input file is text input format, and output format is also text output. Okay, and then I can specify, because sometimes if you want to segregate, you may be processing the example that I have shown earlier is finding the number of employees in each department. So sometimes the number of departments are huge. If it's a very big organization having multiple branches in different countries, then even the intermediate result output from the mapper itself is huge. So which you cannot process in only one machine. You will not be able to bring all the intermediate results in one machine and apply the aggregation. So what you can do is you can apply a concept called partitioning. Send the output of each department to different partitions. Okay, in that case you will get different reducer output. So here now we are passing a simple file of small size. Therefore, I don't want to have multiple reducer. I just want to have only one reducer, but you can also have multiple reducers depending upon the task. Okay. So here I just want to set the number of reducer as 1. And when I run this, the input file will be available in the argument, input argument index 0. The first argument will be the input file and the second argument will be the output path. Okay, the output path where the Hadoop has to store the result. Okay, and then wait until the job is completed. Okay, so this is a conditional statement. So now once you have created a project, Java project like this, you have to create a jar file out of this. Okay, Java archived file. How you can create this? By saying export, okay, jar file, and then click on next. So you specify the path where you want to have the jar file and specify the name of the jar file. Specify the name of the jar file. I just want to create the jar file in. I just want to create a jar file in the folder desktop ATAP. Already I have created. Okay. Otherwise, if I want, I can say word count.jar, word count1.jar, something like this. Okay. See, it is going to create the jar file here. Okay. Okay, you see here, it would have created a jar file. See here, word count1. Okay. So you can create a jar file like this. And once you have created a jar file, you can execute it. So since I'm using a Cloud Lab setup, I have to ensure that the input file, sample.txt is the input file. So I have to upload the input file to Hdfs. So for that, I'm just transferring the input file from my local machine. I'm just transferring the input file from my local machine to cloud environment. Okay, since I'm using a Cloud Lab setup. Already I have, so if this is a Jupyter notebook, upload, say sample.txt is a file which I'm going to use. Sample.txt is a file which I'm going to use as input. Okay, say upload. Yeah, already I have sample.txt. Let me say sample1. Upload. Okay, so it got uploaded here. Sample1.txt. Here sample1.txt. Now what I have to do? I have to ensure that the input file is present in the. Also, you have to upload the jar file here. Okay, also upload the jar file here. Jar file is word count dot. This I'll upload. So it's already there. Word count dot 1 is also already there. I would have uploaded. Okay. Now what I will do is jar file need not be in Hdfs. Okay, but input file must be in Hdfs. So what I have to do is I have to upload the input file into Hdfs. So let me create. Okay, give the credentials. If you install a machine, you can do the same thing. Okay, right. Now I just want to see the files that I have in the local cloud environment. These are all the files that you see here. Okay, all these are shown here. If you want to see what files you have in Hdfs dfs -ls. So ls command will help you to see the list of files and folders in your Hadoop cluster. Okay, usually if you see simply ls, it is showing it is listing out the files and folders in your cloud environment under your login. Here I just want to see the files and folders under Hdfs. So if you see here, these many files and folders I have in Hdfs already stored because I'm using it frequently for Hive, also for Spark, for everything I'm using Hdfs. Therefore, I have a number of files and folders here. Okay, now let me check whether sample.txt is already there. Sample.txt is already there. Let me try uploading sample1.txt. So for writing a file onto Hdfs, the command that you have to use is -put sample1.txt. So it is done. Sample1.txt I have put in Hdfs. Now let me check once again whether it is there. Sample, see here already sample1.txt is not there, only sample.txt is there. Okay, now I just I have written the file sample1.txt in Hadoop. So now if I check again the content of Hdfs, I could see sample1.txt. Where is it? See here, sample1.txt is uploaded into Hdfs. Okay, now I just want to run this file. Run this. I just want to run. For running, the command is Hadoop jar. Please write down the general syntax. Hadoop jar file name. Jar file name is wordcount.jar. Okay, wordcount.jar. And then the next is you have to write the package name. Package name is mypack, and the class name is word count. Class name is word count. And then the first argument is going to be the input file. Input file is sample.txt or sample1.txt, whatever it is, both are same. And then you have to specify some folder name where you can store the output. Okay, I just want to store the output in the folder name mywc. Okay, so this is the folder under which the output of the reducer will be stored. Okay, so let me press enter. So it is going to run a Mapreduce job. Okay, so total input passed to process is 1. See, so from the input file sample.txt, how many splits are created? How many blocks are created? Only one block. Okay, because it's a very small file. Number of blocks or split is only 1. So how many mappers will be used? How many mappers will be used? I have only one block corresponding to the given input file. So how many mappers we need?
One mapper.
One mapper. Very good. So it has been executed successfully. It was showing map 0%, reduce 0%, and then map 100%, reduce 0%, map 100%, reduce 100%. So initially it is finishing the map process, and then it goes for reducer. Okay. So we are able to see the now it is executed successfully. Now I have to see the output content of the output folder. The name of the output folder is mywc. Let me see whether any, see here under mywc I have a file created with the name path-r-0000. This is the file automatically created by this process. Okay, so why is it saying path-r? Yeah, it is the output. It is the output of the reducer. Can you please mute participants? Please mute yourself.
Silent
One second, I'll mute the participant.
హాఫ్ అన్ అవర్ ఒక చోట ట్రాఫిక్ లో అలా స్ట్రక్ అయిపోయింది.
Just mute yourself. Okay, thank you. See here, we are in the final stage. I'll just show you the output and then we can wind up. Okay, so this is the part file automatically created. So this is the output of the reducer. That is the reason why it says path-r. Sometimes we may not require the reducer at all. Supposing display the names of all the employees in the department. This doesn't require any aggregation. So the output of mapper itself will be the final output. So the output would be like path-m. Okay, but since we have used a reducer here, the final output is the output of the reducer. So it is available in this file. So what I want to do is I'm going to check the content of. So to check the content, we will use the cat command. So mywc / path-r-0000. If you see here, I'll be able to see here. For each word, what is the count? Most of the words are occurring only once. Only few of the words in, is, only these words are occurring twice. Okay. So you will see all the words, but the final output is arranged in alphabetical order because of the shuffle and sort phase. Shuffle and sort phase is going to arrange the results in according to the key. Okay. So if the key is a numerical key, then it will arrange in ascending order. If it is a string key, the key is of type string, then it is going to arrange it in alphabetical order. So that is the reason why you see the word big. Okay. Understood how you can
Ma'am, ma'am, I think you're muted again.
sorry. What is happening? Maybe the organizer is trying to mute all, which mutes me too. Okay, so here, what is, I don't know when I got muted. See here. So what I was just saying is, you will be able to see the number of lines of code that you are writing to solve this problem. In case of traditional RDBMS, it is a simple query, select count of star from.
I'm so sorry for the inconvenience. I think again you're muted again.
Okay, anyways, what I'm trying to explain is Mapreduce is based on Java. So in order to solve this problem, we need to write a collection of lines of code. To solve this issue only later, they have developed some ecosystem tools like Hive, HBase, Spark, which will be using some simple line of codes, few lines of code to solve the solution.
Did someone ask any query?
Yes, ma'am. How long will the session will go on?
Yeah, I'm going to wind up now. Okay.
Yes.
So with this, let's wind up so you can try learning about. I have some more examples, but there is no time to explain the rest of the examples. So depending upon the problem, you will decide upon what is the key value, what is the output format and input format for mapper and reducer. Okay, depending upon the problem. So you can explore further if you want to learn much more. If you are really interested in this domain, you can feel free to contact me if you are doing any project, final semester project, or on this. This is my email ID. Okay, feel free to contact me if you need any support in this particular field of learning. Okay. So thank you for the opportunity, Divya, and thank you, audience, for your patience. If there is any query, I'm happy to answer. Otherwise, we can wind up.
Yeah, sure, ma'am. So sorry for all the inconvenience. Because of some settings problem, you had to be muted sometimes. And then the program was initially told to be like 1 hour session. That's why. But then we should be really thankful to the resource person, because when it is a free program, not many people are ready to take for solid 2 hour session. And even now, ma'am has to wind up so quickly because of all the pressures. Else not, the session would have been went a bit long. We expected not this much really, to be frank, this is out of beyond our expectations, ma'am. Thank you so much for your excellent session and for the wonderful efforts and time you have taken for explaining things so clearly to our students. So I'm so happy for taking you here, and so thankful for the wonderful session here, ma'am.
Thank you, Divya.
Yes. So one last question to the participants. If you have any quick doubts, you can ask, ma'am.
Ma'am, can you hear me?
Yes, I can hear.
Ma'am, if you take about
please unmute yourself and again speak.
Yep.
Ma'am, even if we split the big data into n nodes, each.
Sai Shankar, I'm so sorry. Someone is again muting you repeatedly.
Yeah, ma'am. Can we use data compression in Hadoop, ma'am? Because the data is very big to store and to process it. So can we use any compression techniques?
It's not required because data compression techniques are not required. How much big is your data? We can add as many number of nodes as required to, because we are going to do the horizontal scaling, right? So compression techniques may not be required. We can store, we can add as many number of nodes as required to store the actual data itself. Okay, Sai Shankar.
Yes, ma'am.
Yeah, ma'am. Can you hear me?
Yeah.
Like, what
Yes,
is the reason behind the failure of nodes, ma'am? Like,
Mhm.
reasons behind the failure of nodes. Like, what is the reasons? Like,
Yeah, obviously, you don't face any problem with your desktop or laptop. Will it be up and running all the time? There should be sometimes there will be some network issues, isn't it? You'll not be able to connect to the internet. Some machines will go down because of the network issues. You'll not have access to some of the machines. Sometimes it may crash, isn't it? You cannot expect high availability all the time,
okay, ma'am.
isn't it, Jitendra?
Yes, yes, ma'am.
Any
Any
other
other
queries?
questions?
Okay, like so when I share the recorded session with you all, I'll share madam's mail ID. So if you have any queries or if you have anything to discuss with ma'am, you can please feel free to mail to ma'am. Ma'am, thank you so much for the session once again, ma'am.
Thanks, Vivian.
Yes, ma'am. Thank you.